Okay, hi class. So today we're going to be covering chapter 7, preparing parenteral solutions. Topics that we're going to talk about in this video are percentage and ratio strength dilutions. Our learning objectives are to calculate the amount of medication in a solution based on a given percent strength, and calculate the percent strength of a medication in a given solution. The rest of the objectives we'll learn in the next videos. So a percentage and the ratio strength dilution. A solution is a mixture of two or more substances. Solutions may comprise of any of three states of matter. So we have gas, liquid, or solids. Some of the most common solutions exist in the following combinations of components. Solid and a liquid, example would be salt and water. Two liquids, that would be a mixed drink. A solid and a solid, fruit and gelatin. And gas in a liquid would be soda water. In a solution, the substance dissolved in the liquid is called the solute, and the liquid is the solvent. So if both substances are liquid, usually the component representing the greater amount is considered the solvent, and the component representing the small amount is the solute. In general, when comparing two solutions that contain the same components, the solution containing the smaller amount of the solute is considered a dilute. The solution containing the larger amount of solute is considered the concentration. And we talked about concentration in the previous chapter. So the concentration of one substance dissolved in another substance may be expressed as either percent strength or ratio strength. The percent strength or ratio strength of a solution refers to the number of grams per 100 mLs. So we're back to this famous, fraction, where a percentage is written as grams for every 100 mLs, or the same thing in the ratio strength. Remember, so it'll be grams in every 100 mLs. So for this example, 25% is 25 grams per 100 mLs. Okay. The percent strength or ratio strength may be further classified as a solid and a liquid, sometimes referred to as weight in volume, or a liquid and a liquid, sometimes referred as volume in volume. So the weight in volume is the number of grams of medication in 100 mLs of final solution. So that would be X grams of medication over 100 mLs of final solution. Or a liquid in liquid, so volume in volume. That means that the number of milliliters of medication in 100 milliliters of final solution. So X mLs of medication over 100 mLs of final solution. So these are how we will write our questions. Okay, so again, weight will always be grams per 100. So if you're given something in milligrams, we're going to have to convert that to grams per 100. Okay, and milliliters per milliliters for volume. The following ratios are important to remember when setting up problems involving solutions. So weight and volume, problems involving adding a solid medication, so that's the active ingredient, to a liquid such as water that has sodium chloride dissolved in it. So the percent strength of weight volume would be grams of active ingredient over 100 mLs of solution times 100. So that would give us the percent strength. Now for volume, and volume would be the same thing. So, but in this situation, you're talking about volume milliliters over 100 milliliters, okay? So this involves mixing a liquid in another liquid, such as pure acetic acid and water. So again, that percent strength would be X mLs of the active ingredient over 100 mLs of solution times 100. Intravenous solutions are labeled as percent strength, such as dextrose 5%, which is also written as D5W. Normal saline NS is a solution of water and sodium chloride at a 0.9% concentration. Water that is germ-free but has no dextrose or sodium chloride added to it is called the sterile water. So this example, how many grams of dextrose are in 1 liter of D5W? So again, D5W means that it's 5% of dextrose in water, okay? So they're asking us how many grams are in 1,000 milliliters, 1 liter. So remember from our concentrations that 1 liter is equal to 1,000 milliliters. So let's set up our ratios and our proportions. So knowing that we converted 1 liter to 1,000 milliliters. So 1,000 milliliters over X grams, because that's how much grams we want to know that are in 1,000, sorry. And from our problem, 5% dextrose means that there's 5 grams for every 100 mLs, okay? So 100 mLs over 5 grams, we're going to cross multiply. X times 100, 5 times 1,000, divided by 100. So 5 times 1,000 divided by 100 will give us 50 grams. So there are 50 grams in the 1 liter bag. So using dimensional analysis, so we want to know grams. So that's what we're going to leave as the numerator. So 5 grams over 100 mLs times, we want to cancel mLs, so we're going to put mLs on the top. So 1,000 mLs is equal to 1 liter. And then we have 1 liter. So liters cancel, milliliters cancel, and we're left with grams. So 1 times 1,000 times 5 divided by 100 gives us 50 grams. Next example. If there are 30 grams of dextrose in 500 mLs of IV bag, what is the percent strength of this solution? So now they're giving us how many grams are in the whole bag. Now we want to know the concentration from that. So we're going to set up our problem. 30 grams over 500 milliliters times 100 will give us our percent. So that is equal to 0.06 grams per milliliter times 100. That'll give us 6% of a weight and volume solution. Using the ratios and proportion method, so 100 grams 100 milliliters over X grams, because again, this grams per 100 will give us our percent, correct? So, and our bag is 500 mLs over 30 grams. Cross multiply X times 500, 30 times 100. Divide both sides by 500. So 30 times 100 divided by 500 gives us 60 grams. So in reality, that's 60 grams per 100. So that will give us 6% of a weight and volume solution. So percent strength and ratio strength dilution. So express the following items in the following questions as a weight and volume or a volume and volume solution. So the components are 10% dextrose as a weight volume solution. So remember, we said 10%, anything that's percent, change that to grams. So 10 grams per 100 mLs. So that would be our answer. Now express the component of aminosin 7% as a volume solution. So now instead of grams, since this is a volume, it'll be 7 mLs for every 100 milliliters. Okay, so it's very important to pay attention to the solution. So if it's a weight volume, we know it's a gram to milliliters, 100. And if it's a volume, it'll be milliliters per every 100 milliliters. Okay, so then we'll stop here and work on some problems. And then we'll move on to the next chapter. Okay, class, so let's work on a couple problems. So let's look at problem number 2. Technical difficulties right here. So number 2 says, express the following items in questions 1 through 4 as a weight and volume or volume and volume solution. So number 2 is the component of 0.45% normal saline as a weight volume solution. Okay, so let's go ahead and go to the whiteboard and do that problem. Okay, so I've written it here down for you. The component of a 0.45% normal saline as a weight volume solution. So again, we said that anything that's a percent right here, we're just going to remove that percentage and put a gram over 100 milliliters. So that would equal 0.45 grams over 100 milliliters. So if we were to do the next problem, number 3, let me write that down for you. Okay, so number 3 says the component of an acetic acid of 0.25% as a volume solution. So volume means that this is going to be milliliters per milliliters, correct? So now we have our 0.25%. So again, we'll get rid of that percent and put 0.25 milliliters over 100 milliliters. So it's that simple. Let's go ahead and move on to another problem. Okay, so this problem says a total parenteral nutrition TPN order calls for 15 grams of dextrose per 100 mLs of solution. The total volume of the TPN solution is 2 liters. What is the percent strength of dextrose? So this is a good example because sometimes you'll be given more information than you need to solve a problem. So it's very important and it's very key that you pay attention to the question. So this question is asking for the percent strength of dextrose. So this extra information here, the total volume of the TPN is 2 liters. We do not need that information in order to solve this problem. The information that we need is the order calls for 15 grams of dextrose per 100 milliliters. So what is the percent strength? So remember the percent strength is X grams over 100 milliliters times 100. So 15 grams over 100 times 100 will give us 15%. Okay, so again, very important, read the whole problem, read the question, read the problem again, and look for the information that you need in order to solve the problem. Let's do a couple more. Okay, so looking at the book, looking at problem 9, I hate when this thing jumps. It says, based on the label provided in questions 9 through 14, determine the percent strength of each medication. So looking at number 9, we have cleocin phosphate, clindamycin injection, 9,000 milligrams per 60 mLs. And underneath that, you see the concentration of 150 milligrams per milliliter. So remember, in order to convert this to a percent strength, that milligrams, we have to first convert it to grams. So remember, without doing any math, if we're converting milligrams to grams, we would move the decimal space 3 spaces to the left. So looking at that 150, moving it 3 spaces to the left will give us 0.15 grams per milliliter. Now we can go ahead and try to solve this problem. Let me go to the whiteboard. So we said that there was 150 milligrams per ml, and this is our concentration. So in order to convert this milligrams to grams, we were just going to move our decimal, imaginary decimal, 3 spaces to the left, and we would get 0.15 grams per milliliter. And we already have it set up as grams per milliliter. All we have to do is multiply by 100 to get our percent strength. So multiply 0.15 times 100. That's the same as moving our decimal 2 spaces to the left. To the right. And that would give us 15%. Okay. Now let's look at another label. So let's look at problem number 11. So here we have 25 milligrams per 5 mLs. Our concentration underneath is 5 milligrams per milliliter. So we would do the same thing, moving that imaginary decimal 3 spaces to the left in order to get our grams. So let me go to the whiteboard and then so we can do this problem. So our concentration for this one was 5 milligrams per milliliter. So we said that we would move this imaginary decimal 3 spaces to the left and add our zeros. So that would give us 0.005 grams per milliliter. And if we multiply that to 100, we would get 0.005 times 100. That's the same thing as moving our decimal 2 spaces to the right. So we get 0.5%. Okay, let's do 2 more and then we'll cut it this video. Let me see. So this one says, calculate the amount of medication or active ingredient in grams for each of the following. So this is problem number 15. And the other one is problem number 22. So let's do 15 first. So it says amino acid 3.5% in 2.5 liters. So again, we have this little percent here so that we want it in grams, correct? So then let's set up our ratios and proportions. So percent converts to grams, so 3.5 grams per 100 milliliters is equal to X grams per, and liter basically means multiplying this by 1,000 or moving our decimal 3 spaces to the left. To the right. So that'll give us 2,500 milliliters. Okay, so that would be X grams over 2,500 milliliters. So let's cross multiply. X times 100 milliliters is equal to 3.5 grams times 2,500 milliliters. We're going to divide by 100 milliliters. So our milliliters cancel and we're left with grams. So X is equal to, let's put that in the calculator, and we get 87.5 grams. Okay, so the next thing that would be the same thing. So aminophylline 0.4% and 500 mLs. So how many grams are in 500 mLs of aminophylline 0.4%? So again, looking at our percentage, that we're going to convert it to grams. So 0.4 grams over 100 milliliters is equal to X grams over 500 milliliters. Cross multiply. X times 100 milliliters is equal to 0.4 grams times 500 milliliters. Divide by 100. Milliliters cancel. So X is equal to 2 grams. Okay, so this will conclude this video, and I'll see you in the next video. One more thing again, if you have questions, again, feel free to send me a message and I'll respond to you as soon as I can.